We simulated the sun going supernova, and this is what happened. What if our sun suddenly exploded? It's a terrifying thought, right? Used a hyper-realistic simulation based on real astrophysics to see exactly what would happen. For 8 precious minutes, everything on Earth would seem perfectly normal. No one aware that the end was already racing towards us at the speed of light. But that brief, peaceful moment is just the beginning. Our simulation shows the exact, violent timeline of Earth's final moments, second by second. It all starts without any warning. Deep inside the sun's core, the fusion that has fueled our world sputters out and fails catastrophically. Now, for this simulation, we have to imagine the sun is a stellar heavyweight, at least 8 to 10 times its actual mass. Why? Because only stars that massive can create a core collapse supernova. In our model, the sun's core, which can no longer fight against its own crushing gravity, implodes in seconds. It then rebounds in the most powerful explosion the universe can produce. An unimaginable blast of energy and matter erupts outwards. And yet on Earth, 150 million kilometers away, nothing changes. The sky is blue. You feel the familiar warmth of the sun on your skin, having no idea that you're feeling a ghost. The light and warmth you're feeling are 8 minutes old, and the star that made them is already gone. This is the 8-minute delay of final, peaceful window before total oblivion. After 8 minutes and 20 seconds of eerie calm, the first wave of destruction arrives. It's not a sound or a tremor, but a flash of light so brilliant it's impossible to comprehend. The entire sky ignites with a light billions of times brighter than our sun. If you were on the day side of the Earth, your very last sight would be a blinding whiteout that would instantly vaporize your retinas. But this isn't just light. It's a deadly barrage of gamma rays, X-rays, and other high-energy radiation, all moving at light speed. This radiation hits with so much energy, it acts like a physical force. The side of Earth facing the explosion is scoured clean in seconds. The atmosphere is stripped away, boiled off into space. The oceans, lakes, and rivers on the sun-facing side flash boil, turning to vapor. The ground itself, the crust of the Earth, superheated and vaporized. You wouldn't be burned. You and everything around you would just cease to exist. What about the night side of the planet? Shielded for a few moments, but that won't last. The sheer intensity of the energy would wrap around the planet, sterilizing what's left. Even before that, a silent messenger of doom would have already passed through the entire planet. Neutrinos. These ghost-like particles are blasted out from the collapsing core, carrying away 99% of the star's gravitational binding energy. They travel at nearly the speed of light and pass through matter like it's not even there. While the neutrino flood would be immense, their interaction with you is so weak they would pass through your body, the oceans, and the Earth's core harmlessly, serving only as the universe's silent announcement that the explosion had begun. The first blast of radiation was just the opening act. The real planet killer is the shockwave, colossal expanding sphere of the sun's own matter, launched into space at unbelievable speeds. Based on models of real supernova, our simulation shows this wall of superheated plasma traveling at up to 30,000 kilometers per second. At that speed, the trip from the sun to what's left of Earth is terrifyingly quick. While light took over 8 minutes, this physical wall of debris crosses the 150 million kilometer gap in less than an hour and a half. What it finds is a charred, irradiated, and half-vaporized husk of a world. The impact is absolute and final. This isn't an explosion on Earth. It's a collision with the mass of a star moving at cosmic speeds. The planet is utterly disintegrated. The rocky mantle and iron core are torn to shreds and swallowed by the expanding supernova remnant. The shockwave continues its rampage through the solar system, erasing any sign that Earth and its closest neighbors ever existed. Our simulation doesn't just stop with Earth. We watched as this expanding cloud of destruction wipes out our entire cosmic neighborhood. Mercury and Venus, being closer to the Sun, were destroyed minutes earlier. The shockwave hits Mars's orbit less than 2 hours after the initial explosion, and the red planet is dismantled. The asteroid belt is next, its millions of rocks swept away like dust. The gas giants, Jupiter, Saturn, Uranus, and Neptune are much bigger, but they don't stand a chance. As the shockwave reaches them over the next few hours and days, it slams into their massive atmospheres. The outer layers of these giants are stripped away, and their beautiful ring systems and moons are obliterated. The blast would disrupt their powerful magnetic fields and could even knock them into new chaotic orbits or throw them out of the solar system entirely. What was once a clockwork solar system becomes a chaotic, expanding nebula of gas and debris. And at its center, where our sun used to be, our simulation leaves a terrifying new object. The ultradense remnant of the star's core. It could be a rapidly spinning neutron star, or, if the star was massive enough, a black hole. Our solar system is gone, placed by a beautiful but deadly supernova remnant, glowing tombstone marking where our home used to be. Okay, after witnessing that ultimate apocalypse, it's time for the most important part of this video, a reality check. The absolute chaos you just saw is a simulation of something that, thankfully, can't actually happen. Our sun will never go supernova. The reason is simple. It's just not big enough. A star needs to have at least 8 to 10 times the mass of our sun to trigger a core collapse. Our sun is what's known as a yellow dwarf. It just doesn't have the gravitational muscle to create the conditions for that kind of catastrophic implosion. It's in a stable, happy balance, fusing hydrogen into helium, and it has enough fuel to keep doing that for another 5 billion years. So what will actually happen to the sun? Its end will be far less violent, but still incredibly dramatic. In about 5 billion years, when it runs out of hydrogen in its core, the core will shrink and heat up. This will cause the sun's outer layers to swell dramatically, turning it into a red giant. It will grow so large it will swallow Mercury and Venus, and its fiery surface could even reach Earth, scorching our world. After that phase, the sun will puff away its outer layers, creating a beautiful glowing shell called a planetary nebula. Left behind will be the smoldering, Earth-sized core, a white dwarf. This incredibly dense remnant will no longer produce energy, and will simply cool down and fade over trillions of years. Our sun's end isn't a bang, but a long, slow fade to black. The simulation we ran wasn't just some sci-fi fantasy. It was built on decades of real research into how massive stars die. Since scientists can't exactly get a front-row seat to a real supernova, they use incredibly powerful supercomputers to model the complex physics. These models are called 3D hydrodynamic simulations, and they can take millions of hours of computer time to run. They model everything from the core collapsing in on itself to the messy, turbulent plumes of gas that blast outwards. These simulations have shown us that supernova explosions aren't perfect spheres, but are lopsided and chaotic, shaped by things like turbulence and neutrino interactions. By simulating these explosions, scientists can figure out how supernova forge and scatter heavy elements, like the carbon in our bodies and the iron in our blood across the universe. These are the very elements that make new stars, new planets, and life possible. So while our simulation showed a hypothetical end for our world, the science behind it actually helps us understand how new ones can begin. The death of a star in a supernova is one of the most violent and creative events in the entire cosmos. It's an engine of destruction, but it also seeds the universe with the building blocks for new stars, planets, and maybe, just maybe, new life. Our simulation is a terrifying glimpse into that raw power, a reminder of the incredible forces that are constantly at play all around us. But it should also give you a feeling of deep appreciation. We live in a stable solar system, orbiting a stable star that's in the prime of its life. It won't ever threaten us with a supernova. Instead, it gives us the steady, life-giving energy that has allowed our world to flourish. The sun's quiet, predictable nature is the real miracle, a cosmic lottery we won and get to experience every single day. If you enjoyed this trip into the heart of an exploding star and want to explore more cosmic what-ifs, be sure to subscribe and hit that notification bell. Let us know in the comments what other cosmic catastrophe you'd like to see us simulate next. Thanks for watching.